Here in section 3 we have the sum and difference identities for cosine. Sum and difference identities for cosine. So first thing to note that the cosine of a minus b, or the cosine of 45 minus 30, does not equal the cosine of 45 minus the cosine of 30. Long drawn out explanation for this. We'll save that for your work in calculus for those of that are moving on. For right now we're just going to ask you to know these, and by the time the day or the homework assignment is over, you should know these. Cosine of a plus b, or the cosine of two different angles being added together, is the cosine of a times the cosine of b minus the sine of a times the sine of b. So notice that our pattern follows, even though we have a plus here, we're going to end up subtracting our two different products. And the cosine of a minus b equals the cosine of a times the cosine of b plus the sine of a times the sine of b. We have the same pattern there, cosine times cosine, cosine times cosine, sine times sine, sine times sine. But we have what I would consider to be opposite operations between the products there. This is a sum, but we subtract our two products. This is a difference, and we add our two products. And we can use that in conjunction with our unit circle to find other values in exact form. Keeping in mind exact form typically means either as a decimal that terminates, or more than likely a radical form. Just writing a whole bunch of decimals off your calculator is not an exact form. So here, to get 15 degrees, we'd probably go to our unit circle and say that 45 minus 30 equals 15 degrees. So another way of writing 15 degrees, 45 and 30 are both on our unit circle. So we expand that out, we'd have cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. Now we'd go to our unit circle, pull those values off there. Cosine of 45 degrees is square root of 2 over 2. The sine of 30 degrees is the square root of 3 over 2. The sine of 45 degrees is square root of 2 over 2. And the sine of 30 degrees is 1/2. And now we have the square root of 6 over 4 plus the square root of 2 over 4, or eventually the square root of 2 plus the square root of 6 plus the square root of 2 all over 4. So there's our exact answer for the cosine of 15 degrees. And what you'll find happens here is these types of answers are going to be very common or repetitive here because we're using the same values off the unit circle, 30, 45, and 60, and the negative and positive versions of that. So you'll see those occur again and again and again. So as we move on here, cosine of 5 pi over 12, we're probably not going to be able to know what 5 pi over 12 is off the top, or two angles that add to be 5 pi over 12, so it might be a good idea is to pull this 5 pi over 12 off to the side somewhere and convert it over to a degree measure. So I'm going to multiply it by 180 over pi, noticing that the pi's will cancel. The 12 and the 180 will cancel to be 1 and 15. So we're actually finding the cosine of 75 degrees. Now that we know it's 75 degrees, we could do our sum or difference. In this case, again, we have choices, but the most obvious of which I think is 45 plus 30. And we expand that out yet again, cosine 45, cosine 30. Noticing this time we're subtracting sine of 45 times the sine of 30. And we make our substitutions in here. Cosine of 45, square root of 2 over 2. Sine of 30, or cosine of 30, square root of 2 over 2, or square root of 3 over 2. Sine of 45, square root of 2 over 2, and the sine of 30 is 1/2. Notice the same answer. I'm going to shortcut it this time. Minus the square root of 2 all over 4. The same answer as above, but an opposite operation in between there, because we did the sum of two angles instead of a difference. Oh, one more time here. Cosine of 45, or of 105, we could use 60 plus 45. So I'll expand that out to be the cosine of 60 times the cosine of 45 minus the sine of 60 times the sine of 45. Making our substitutions in here, the cosine of 60 from our unit circle is 1/2. The cosine of 45 is square root of 2 over 2. The sine of 60 is square root of 3 over 2. And the sine of 45 is square root of 2 over 2. So we'll wind up with square root of 2 over 4 minus the square root of 6 over 4, or as a single fraction, square root of 2 minus the square root of 6 all over 4. So as I mentioned, you have the same types of answers each time. The order might change, the operations might change, but we're working with those same values each time, so they will be very similar. Notice number 4 is one where it looks like we work backwards. It's already expanded form. So hopefully you notice with this minus sign in the front, it falls into the pattern of the cosine of A plus B. In this case, A is 87, B is 93. If we add 87 and 93, we're getting 180 degrees, and this one happens to be on the unit circle, so the cosine of 180 degrees is negative 1. So we just work backwards, condense this down into a formula, simplified, and actually found that value on the unit circle. As we continue on, we review our cofunctions. Recall this from back in chapter 2. Cosine and sine are cofunctions. Tangent and cotangent are cofunctions, and secant and cosecant are cofunctions. What that simply means is their angles are complementary if they're equal to each other. So the cosine of 30 degrees is equal to the sine of 60 degrees. The cotangent of 20 degrees is equal to the tangent of 70 degrees, something like that. Or down here, the cosecant of 15 degrees is equal to the secant of 75 degrees. If the functions are equal to each other, they're cofunctions, and their angles are complementary. 15 and 75 is 90, 20 and 70 is 90, 30 and 60 is 90. And we can prove that with our identities. It says cosine of 90 minus theta is going to equal sine of theta. So notice I have a difference formula here. Let's call those A and B. So the cosine of A minus B is the cosine of 90 times the cosine of theta minus, or not minus, plus the sine of 90 times the sine of theta. If we go to our unit circle and make our substitutions for the angles that are there, the cosine of 90 degrees is 0 times the cosine. The sine of 90 is 1 times the sine. 0 times anything is 0, so we're left with 1 times sine, or you can see it does equal the sine of theta like we have over here. And again, just continuing on with our cofunctions here with 5, 6, and 7. Notice that tangent and cotangent are cofunctions, which means our angles of x and 25 add to be 90. We solve from here by subtracting 25 from both sides, and our x is 65 degrees. We'll try that a second time. Sine and cosine are cofunctions, so their angles of x and negative 30 should equal 90. So I'll add 30 degrees to both sides, and in this case x equals 120 degrees would be our value. 120 and negative 30 are complementary angles. And one more time here, I'll put it in radian format first. 3 pi over 4 plus x equals 90 degrees. Well, 90 degrees is a radian is pi over 2. So we'll subtract 3 pi over 4 from both sides. So we have 2 pi over 4 minus 3 pi over 4. So x equals negative pi over 4 is our radian measure. Some of us might want to convert that to an angle. So if we pulled 3 pi over 4 off to the side, I say we're an angle over to a degree, 180 over pi. I'll cancel the pi's. 4 and 180, 1 and 45. So we're finding the cosine, or cosecant of 45 degrees equals the secant of x. So we have 45, oops, try that again, let's backtrack. I didn't take the 45 times the 3, it's the cosecant of 135 plus x equals 90, and we subtract the 135 from both sides, and we get x to be a negative 45 degrees. So ideally we have our answers a radian, but we could convert it over degrees and do the same thing. Oh, we can't end without having an identity. Oh, we have a couple of problems to go first, I guess. So we have the cosine of 180 minus x. We're going to simplify this down, first of all, by expanding it out. The cosine of 180 times the cosine of x plus the sine of 180 times the sine of x. We'll make our substitutions in here. The cosine of 180 is negative 1. The sine of 180 is 0. 0 times anything is 0. So we wind up with a simplified version here of negative cosine x. We'll repeat the process one more time. Cosine 2 pi times the cosine of x plus the sine of 2 pi times the sine of x. Making our substitutions, the cosine of 2 pi goes all the way around the circle is 1 times the cosine. The sine of 2 pi is 0 times the sine, and 0 times anything is going to cancel out. So we have a simplified version here of cosine. Number 10 tells us to find the cosine of a plus b with this following information. Sine of a is 3/5, cosine of b is negative 12/13. A and b are both in quadrant 2. So ultimately, as we get going here, we're trying to find the cosine of a times the cosine of b minus the sine of a times the sine of b. We're going to use this information. So over here on the side, I'm going to set up a little chart for angles A and B and find x, y, and r for each of those. That way we can find both sine and cosine for our angles very readily. So for angle A, sine is 3/5. Well, sine is y over r. If we use our Pythagorean theorem, 3 squared plus x squared equals r squared. I'll go ahead and write that down. But maybe we ultimately know that's a 3, 4, 5 triangle. And because we're in quadrant 2, that 4, or x value, is negative. Same thing for B. B is cosine, so we're given x to be negative 12 and r to be 13. X is a negative value for two reasons. Number one, we're in quadrant 2, and for this fraction to be negative, one of the two values has to be negative. R is always positive. So again, same idea, negative 12 squared plus y squared equals 13 squared if we use our Pythagorean theorem. Or if maybe remember from our work in geometry, y would be 5. So now that we have x, y, and r, we can find the cosine and sine of each of those two angles. So from angle A, the cosine is negative 4/5. The cosine of angle B is negative 12/13. Going back to angle A, the sine of angle A is 3/5. And the sine of angle B is 5/13. Over here we have 48/65 minus 15/65, or simplifying we get 33/65 as the cosine of A plus B for this given information. Now, as I went to say here earlier, we can't let the day pass without one identity. Verify that the following identity is true. Secant of 3 pi over 2 minus x is going to equal negative cosecant of x. Well, we don't have an identity for the secant of the difference of two angles, but we do know secant is 1 over cosine. So I'll rewrite this as 1 over the cosine of 3 pi over 2 minus x. Leaving my numerator as 1, I'll expand this difference formula out to be cosine 3 pi over 2 times the cosine of x plus the sine of 3 pi over 2 times the sine of x. We'll make our substitutions from our unit circle. 3 pi over 2 is 270 degrees, so the cosine of 3 pi over 2 is 0. So 0 times the cosine of x, and the sine of 3 pi over 2, or the sine of 270 degrees, is negative 1 times the sine of x. As we simplify here, obviously I still have 1 in my numerator. 0 times cosine is 0. I have a negative sign here. And 1 over negative sine is negative cosecant. There is our identity. And I believe that concludes our sum and difference formulas for cosine, because we will start sine with our next lesson.